Welcome, ladies and gentlemen, to sqadia.com. My name is Mohammad Osama, and today we are talking about data handling in medical statistics and research. The section that we are going to cover right now is about data entry checks, which is a very important part in the research process. In this, we are going to talk about the methods to check for data, checking data using frequency distribution, and checking for consistency. We're also going to talk about checking data using a histogram and a scatter plot. So data entry checks. So if the data has been manually entered and not using an automatic data capture program, then some checking for errors is essential during the research process. So the things that we can do to ensure good data quality and to ensure that proper checking of the data entry is being carried out is, first of all, check early, because that is the best thing that you can do. You have very few participants. It's very easy to check all of them, and you can make corrections at the start of the research because it is easier, and you can then make sure that the further process goes smoothly and accurately as compared to if you check later and you have no way to solve the problem. Check a random sample of forms for data entry accuracy. So just select a few random sample of forms and check for the data entry if that is accurate. And if this reveals any problem, then further checking or more extensive checking of other forms and subjects is needed. Key variables. Always keep an eye on your key and outcome variables. So if feasible, consider checking data entry forms for key variables for all the participants if possible, such as your primary outcome variable, because that is the most important thing. Any one or any single outlier can actually change your data remarkably and your results and your analysis. Range checks. So always check if the subjects have the values within the specified range. For example, unless the data entry scheme has inbuilt range checks, tabulate all data to ensure that there are no invalid values which are out of the range checks. Always look for consistency of the data. Check for any impossible or unlikely combinations of responses, such as a male with pregnancy. Now that is not possible, so always check for consistency like that, giving a bird's eye view on it. Or always check for outliers as well. For example, such as one recording of blood pressure in a subject is very different from all the others for the same subject. Like in all of the other values, his blood pressure was in normal, but one was remarkably abnormal, so that can be a mistake. So always check for consistency within the data, within the variables, and as well as within the subject. Always keep the original forms so that you can refer back to them in any kind of mistake or problem. Always handle the missing data appropriately. One problem that usually occurs is that sometimes we do not differentiate between the missing data, because it can occur in two ways. For example, there is a questionnaire and the person who was filling that questionnaire did not fill out a specific variable. So that is why we did not have that specific variable filled for that subject. On the other hand, it is also possible that someone was doing data entry and that person missed or forgot to enter that value. So these are two different scenarios. So to ensure that a difference between these two scenarios, you can use is that if the value was missing in the form or the questionnaire, then either mention a dot or any impossible value, like for example 999, or anything that you have decided in coding to denote as a missing value. Mention that. So when you actually overview or check for data entry, you can see that either it was because of the absence of the response in the form, or either it was because of the mistake of the person who was doing the data entry. Snowballing errors. Snowballing is like Sometimes when you find one error, it may lead to others being uncovered as well. For example, if someone was doing the data entry and he mistakenly entered correct incorrect value at an incorrect spot, so what would happen is that that spreadsheet would have one entry that was either wrongly mentioned or either it was missed, and all of the following entries may be in the wrong columns or rows, and that would result in a snowballing error that you would have to identify and that you would have to correct. Now, digit preference. Sometimes it happens is that whenever some researchers are collecting the data or when they're entering the data, they try to round off the figures. So a particular digit is more common than others and may indicate inaccurate reporting. For example, if some researcher is recording blood pressure and they're recording it to the nearest 5 or 10 millimeters of mercury, and you'd always have the responses in round off to nearest 5 or 10, so you can identify now that there is a problem and there is actually a digit preference at the level of data collection or data entry. Secondly, frequency tabulations will show if there is a digit preference, and how we can use frequency tabulations for data entry checks we are going to talk in the upcoming slides. Now, scatter plots. Scatter plots is another way in which we can identify values which are inconsistent with an individual or a subject. For example, such as it would be unexpected to have a greater pre-pregnancy weight than full-term pregnancy weight, because as the fetus grows, the weight is expected to increase. So if that is the case, so a scatter plot can identify it and you can actually check if that is a problem. Moreover, a scatter plot would show this individual as being far away from the rest of the subjects, and we are going to take a look at a scatter plot at how would that identify it. And further checks could be made to see if these values represent an error. Now, statistical analysis. Some data entry problems only come to light when the data is analyzed, and so there may be a need to go back to the original forms later on. So that is the reason why we mentioned in this slide that always keep the original forms. Moving on, in the previous slide we mentioned about frequency distribution. So let's take a look how we can use frequency distribution for the data checks. Here we have a variable, for example DOV, and here's the frequency for it, and we see that there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have the frequency so on. So 0, 1, 2, 3, 4, 5, 6, 7, 11, 14, 15, and it goes on. But there is this one value which is actually, it seems like an outlier. So it can maybe a mistake, and it is only one entry for this DOV. So we need to revisit back the data, and we can check if this one is by mistake or if it actually is present in the data. Now, second one was checking for consistency. So this table here shows respiratory parameters at 2 times in group of infants in a research study. So we have TV standing for tidal volume and HB for hearing bureau inflation reflex. So TV1 and HB1 and TV2 and HB2. This denotes that these values have been taken at 2 different time frames. So here if we look at the data, so we can see that the tidal volume is around 4 to 5 to 6 to 7. So it's a 1 digit with 2 decimal places. But if we talk about HB, so it is around 2 to 3 digits with 2 decimal values. So if you look here, we can see that there is a consistency among the entered values. Here once again we have the consistency among entered values, except for here because it looks very small for the value for an HB1, so we can revisit the original data for it. Once again, if we look at this highlighted part, so 4.85, 5.8, so there's a consistency, but this consistency here has been altered or disturbed. And similarly, this consistency here has been disturbed as well. So this shows us that there has been problem in the data entry in which these two columns have been substituted. So these values were supposed to be here. So if we put these values here, so it makes sense and there would be a consistency here. But before doing that, make sure of it from the original data. So that's how you can check for consistency. Okay. Now here in this slide, we can see that how we can use a histogram to check for the data. And here we have a histogram in which we have a weight standard deviation along the x-axis and density along the y-axis. So we can see it is a pretty much normal graph, but we can see that here it is one outlier with a standard deviation of 4, which is remarkably away from all of the remaining data. So here it is an outlier and we need to make sure if that is a mistake or if that is a correct value. So we need to go and check the data again for this, and that's how we can use histograms for checking the data for its consistency and for its correction as well. Now, we can also use a scatter plot, as we already mentioned in the previous slides, for checking of data. So here we have a scatter plot in which we have weight and height standard deviation score. So weight is on the, you can see y-axis, and height and standard deviation is on the x-axis. So it is expected that these two should be correlated. So, and the data also shows the same. But if we can see that this one dot here, it is pretty much of an outlier because it is remarkably away from all of the other data entries. So the outlying value for the weight, as this is clear, as it is well away from other points, but as stated above, it was found to be correct. So it is not necessary that any outlier that you see is actually a mistake. There can be genuine outliers in your data as well. So always go and check your data for those problems. So usefulness scatter plot to check for outliers also provide a warning that some apparently outlying values are in fact correct, as I already mentioned. So always do not consider that if there's an outlier that is a mistake. No, it is also possible that some outliers may be genuine. So always look for the data for their authenticity. So that was all about this section of the data in which we talk about data checking, and I hope you learned something new out of it. And thank you very much for watching sqadia.com. Keep on watching Sqadia for more lectures like this. Thank you.